Hello students, welcome back to our channel. Students, in this video we are going to discuss a very important topic from class 12th physics chapter alternating currents. This is one of the most important topics of your entire syllabus and a question based on this topic, which is transformer. So the question based on transformer comes many times in board exams, in school exams, and the weightage of question is 3 to 5 marks. So there is a direct question based on the working, principle, diagram and construction of the transformer, or you can get a numerical based on this. So overall, everything that we are going to study in this lecture is very important from examination point of view. So let's start. What is a transformer? Students, transformer is a device. It is a device. It is a device which is used to step up or step down. Step up means to increase and step down means to decrease. It is a device which is used to step up or step down the magnitude of alternating voltage and current. It is a device which is used to step up or step down the magnitude of alternating voltage and current. The most biggest advantage of alternating current and alternating voltage over direct current and direct voltage is this, that the value of alternating current and alternating voltage can be increased or decreased according to the need. If you have a battery of 10 volts, a DC battery of 10 volts, then the voltage of that battery is going to be 10 volts forever. You cannot change the value of that voltage. But in case of alternating current or alternating voltage, we can easily increase and decrease the value of alternating current and voltage using a device which is called transformer, right? How it does this? So for that, let us first understand the principle of transformer. Working of transformer. What is all this? I'll just explain you in a short while. Working of transformer is based on the phenomena of mutual induction. Working of transformer is based on the phenomena of mutual induction or mutual inductance. You all must have studied the chapter electromagnetic induction, in which we have studied this phenomena mutual induction, in which if we change the current through one coil, then a current is induced and EMF and a current is induced in the neighboring coil, right? When the current is changed in one coil, and EMF and current is induced in the neighboring coil. So in the in the construction of transformer, now in the construction of transformer, here we have two coils, right? one is called the primary coil and the other one is called the secondary coil. This one is a primary coil. This one is a primary coil and this one is a secondary coil, and this pink one is a laminated soft iron core. I'll write it. I'll write the names of all these, but first let me draw something very important. Uh, just let me complete the diagram first. Okay, this is called, this one is called, this is the laminated soft iron core. Okay, what is the meaning of this whole thing? Laminated soft iron core means what? This that you are saying, that you are seeing is not a two-dimensional structure, it is a three-dimensional structure like this. It is a three-dimensional structure like this, but you don't have to draw that three-dimensional structure because in NCERT only this diagram is given. So we have drawn this diagram, right? So we are looking at this from this angle, so we will see this. Yes, so it is a three-dimensional structure like this, right? So this is, instead of taking a whole block of soft iron of this shape, what we do, we make thin sheets of this shape and join them together. These are thin sheets which are joined together to make this core, right? These are the thin sheets of soft iron which are joined like this to make this core. Okay, why we do this? Why we do not take a bulk piece of iron, and instead of taking that bulk piece, we have joined so many thin iron sheets to make this core, just to reduce the eddy currents, right? If we would have taken a bulk piece of iron, then when the current in this coil changes with time, then eddy currents induce in the bulk piece, and due to the formation of those eddy currents, too much heat will produce in this iron core, which is simply a loss of energy. So to reduce that loss of energy due to eddy currents, we take a laminated core instead of taking a bulk piece of soft iron, right? So okay, now let us get back to the easy diagram. And on this soft iron core, two copper coils are wounded like this, right? Okay, and the AC, which is to be stepped up or stepped down, is connected to one of these coils, and after stepping up or stepping down, the voltage or current that we are going to get across a resistance, and that resistance is connected to the other coil, which is called the secondary coil, right? With the primary coil, we connect the input AC that we have to step up or step down, and with the secondary coil, we connect an output resistance across which we will get the output, that is the stepped up voltage or current, or stepped down, right? So this is called this is called the primary coil. This one, sorry, this is the primary coil, and this is secondary coil, and this is laminated soft iron core. So this is the construction, right? Now let's come to the working. Let's come to the working. Let us say the number of turns NP, NP and NS. NP and NS. We will use subscript P to represent any parameter of the primary coil and subscript S to represent any parameter of the secondary coil. So NP and NS are what? Number of turns in primary and secondary coils, right? Number of turns in primary and secondary coils. And EP voltage applied across primary coil and ES is voltage obtained across secondary coil, right? Okay. IP and IS are currents in primary and secondary coils, right? IP and IS are currents in primary and secondary coil. Now suppose we have applied a voltage EP in the primary coil, so we can write EP from Faraday's second law. EP is minus NP d phi by dt, right? This is what the Faraday's second law says. And the voltage that we apply across the primary, that is the applied voltage, right? And now since this is an alternating voltage, so the current in this coil will change in sinusoidal way, right? It will first increase, then decrease, then it will change its direction. So basically the current in the primary coil is changing with time, and due to which any coil which is kept in the vicinity of this coil, any neighboring coil, right? So this is the neighboring coil. So in any neighboring coil, a current will induce according to the principle of mutual induction. So when the current in this coil, alternating current is a current which is not constant. So when we apply alternating current in this coil, so that current is changing with time. And due to this changing current, a current is induced and hence an EMF is induced across its ends. So that is the output voltage that we are going to get in the secondary coil. But how that output voltage is different from this? Assuming that there is no flux leakage, that is, the total flux that is associated with this coil is equal to the total flux which is associated with this coil. Since these two coils are very close to each other, so most of the flux which is linked with this coil will be linked with this coil also. So we can say that for secondary coil also, we can say that ES is minus NS into d phi by dt. So if we divide these two, we get ES by EP equal to minus NS d phi by dt upon minus NP d phi by dt. So d phi by dt gets cancelled out, minus is also cancelled, and finally we got this equation on which the entire working of transformer is based, and the equation is ES by EP is equal to NS by NP. So the ratio of voltage and current is exactly same as the ratio of number of turns in the two coils. So if we keep the number of turns in this coil 10 times the number of coils, the number of turns in this coil, if the number of turns in this coil are 50 and the number of turns in this coil are 500, then the voltage is automatically going to be 10 times more than the primary voltage, right? So if number of turns in this coil are 50 and number of coils in this coil, number of turns in this coil are 500, then if we have applied a voltage of 10 volt, then we are going to get a voltage of 100 volt across the secondary. So this is how it works, right? So to increase the voltage, we just have to increase the value of number of turns. If we just have to increase the number of turns in the secondary coil, and such type of transformer is called step up transformer, which increases the voltage, right? So in step up transformer, in step up transformer yes, for step up transformer we need ES greater than EP. Voltage across secondary should be more than the voltage across primary, and this can be simply achieved by keeping NS greater than NP, right? If the numerator of this is more than the numerator of this, so obviously if the numerator of this is more than the denominator, then obviously the numerator of this will be more than the denominator of this, because these two ratios are equal. And this ratio is called this or this, because both these are equal. This is called the transformation ratio. This is the transformation ratio. Clear? Okay. So this is step up transformer. So in case of so what is the value of transformation ratio? This transformation ratio is represented by K. So in step up transformer, numerator is more than the denominator, then obviously the value of K in step up transformer, the value of K is more than 1. And in step down transformer, in step down transformer we need less voltage across the secondary as compared to the primary. So for that case we have to keep the number of turns in secondary less than the number of turns in primary, and we can say that the transformation ratio is less than 1 in such type of transformer. But there is no magic happening in this case, otherwise you can think that how magically the voltage is increasing or decreasing to any extent, but this is not magic, because in electrical circuit energy is represented or energy is expressed in two ways. One is voltage and one is current. So we can say in an ideal transformer, when there is no energy loss, in an ideal transformer, no transformer is ideal because there are various energy losses in a transformer that we will going to study shortly. In an ideal transformer, output power, because there is no energy loss, then the output power is equal to the input power. And what is the output power? Output power is ES into IS, because the formula of power is current into voltage. right? So the output power is ES into IS and the input power is EP into IP. So we can say that ES by EP, right? ES by EP is equal to IP by IS, IP by IS, right? So in step up transformer, voltage increases, right? Voltage increases and current decreases. If this ratio is more than 1, because ES is more than EP, then obviously IP is more than IS. So in case of step up transformer, one type of energy, that is voltage, one type of energy increases, but the other type of energy, that is current, that decreases. So there is a balance of energies, right? And so the step up transformer increases the voltage but decreases the current, and in step down transformer, in step down transformer, ES is less than EP, therefore IS is greater than IP. So voltage decreases but current increases. So if the transformer is not ideal, real transformer, in case of real transformer, we can say that the efficiency of the transformer, eta, efficiency of the transformer is like the efficiency of any other machine, which is power input percentage efficiency is power output, sorry, by power input divided into 100. So suppose the efficiency of a transformer is 80%, right? If the efficiency of a transformer is 80%, then what is the meaning of this statement? So if the efficiency of a transformer is 80%, we can say that if the number of turns are 10 times the number of turns in secondary are 10 times the number of turns in primary, right? If the number of turns in secondary is 10 times the number of turns in primary, then the voltage is going to increase only 8 times, right? If the number of turns in primary are 50, in number of turns in secondary are 500, so number of turns are 10 times. So if we have applied a voltage of 10 volt, so we are not going to get 100 volt over there, we will get only 80 volt, because the efficiency of this transformer is only 80%, right? Okay, so why the efficiency of a transformer is less? Due to the energy losses in transformer. So there are various energy losses. There are various energy losses in transformer. First one is copper loss. First one is copper loss. Copper loss means the amount of heat which is produced in copper coils due to the flow of current in it, right? These coils are made up of copper, right? So if a continuous flow of current is maintained in the coils, then obviously a heat is produced in the copper wires, because the formula of heat is I square RT, और heat direction नहीं देखती है, right? So if the direction of current is in any way, so the heat is always going to produce in the same manner, because it is I square RT, so there is no direction. So continuously if the current is increasing, decreasing, so lots of heat is produced in these copper coils, and that loss of heat is called copper loss. Obviously heat is a form of energy, so energy is getting wastage. Number 2 is called iron loss. Number 2 is called iron loss. Iron loss means the same thing which happens with the iron, soft iron coil. We know that the iron is also a metal, so it is a good conductor of electricity. So when the current flows through the copper coils and eddy currents, few eddy current, very small eddy currents, because the core is laminated, so very small eddy currents flow in the laminated soft iron core also. So due to which heat energy is produced, and that is also a kind of energy loss. Number 3 is called flux leakage. In this working, we have assumed there is no flux leakage, because we have taken d phi by dt for primary also and d phi by dt for secondary also. So we have assumed that there is no flux leakage, right? But this is not true. There is some flux leakage, and if there is some flux leakage, so the flux associated with the or linked with the secondary coil is less than the flux linked with the primary coil, and due to this these two ratios are not going to be equal. So there is some loss of energy. Number 4 is called hysteresis. What is hysteresis? Since the current in this core is first increasing, because this is an alternating current, so current in this core is first increasing, then decreasing, then first increasing, then again decreasing, then increasing, then decreasing. So what happens then, the material, that is soft iron, it gets magnetized, right? Because the small domains which are present in this case, they get magnetized when the current increases, and they get demagnetized when the current decreases. Again they get magnetized when current increases, and again they get demagnetized when current decreases. So due to this, due to the alignment of those domains, obviously energy is spent when the domain gets aligned in a particular direction, and then again they get de-aligned, then again they get aligned. So energy is lost in this process, and that is also a kind of energy loss. So that energy loss is called hysteresis, and due to hysteresis also the efficiency of transformer decreases. And last, a very important energy loss is called magneto restriction. Magnetorestriction is the humming noise of transformer. Humming noise of transformer. If you have ever walked past by a transformer, you must have heard this noise, a humming noise like this kind of noise comes from the transformer, and obviously sound is a form of energy, so this is also a wastage of energy. So where is that sound coming from? When current increases in these coils, when we know that when current passes through this coil, the current as looked from one side of the coil, the current looks anti-clockwise, and from the other end it looks clockwise, like, right? So one end acquires north polarity and the other end acquires south polarity, but after some time the direction of current reverses. So the end which had north polarity, now it acquires south polarity, and the end which had south polarity acquires north polarity. So what happens, continuously the ends, the polarity of the ends is getting exchanged, and the strength of the polarity is also getting, first it is increasing, then it is decreasing, because the strength of current is increasing and decreasing. So what happens, they attract each other, and then the attraction reduces, then they again attract each other, then attraction reduces, then again attract each other, attraction reduces. So they do like this, right? So due to this, a noise is produced due to the collision of this with air molecules. A noise is produced, and that is called the humming noise of transformer or magnetorestriction, which is also a kind of energy loss. So due to all these energy losses, we can say that the efficiency of transformer is never 100%, it is somewhere around 70-80%. So where a transformer is used. A transformer is used anywhere where we need to increase the value of alternating current or voltage, or we need to decrease the value of alternating current or voltage. For example, in power stations where the energy is produced, the voltage is in lakhs, right? And in our homes, the voltage is 230 volt. So when the voltage, when this electricity comes from the power stations to our houses, it gets stepwise, it gets stepped down to 230 volt from lakhs of the value. So in between you will find 2-3 transformer. First, the when the energy comes to the whole locality, then there is a substation having a step down transformer, then it gets distributed to subdivisions, and then again it gets distributed to individual houses. So during this process we have three four transformers which continuously step down the value of alternating voltage and hence increase the value of alternating current. Okay, we have transformers in our chargers also, right? The mobile phone charger or the laptop charger that you are using to charge the devices, they also contain transformers in them, because the household supply is 230 volts and the mobile phone battery or the laptop battery gets charged on a voltage of 10 volt or 20 volt. So we have to first step down that 230 volt to 10 volt or 20 volt, only then the battery of our devices can get charged, right? So this was everything about transformer. It is one of the most important topics of the entire syllabus. To prepare it very carefully, I'll meet you in the next lecture. Till then, all the very best.